Hello, these are notes 5 called factoring expressions. We've been doing a lot of work so far with properties of numbers, specifically the distributive property. The distributive property looks like this right-hand side of the equation, where we would give the number on the outside to each thing on the inside. So we would do 4 times 2x and 4 times 1. Now we're going to do the opposite of the distributive property. That's what factoring means. Factoring means doing everything backwards. So we have the answer, and we need to write it with that number on the outside. There are 3 steps that you're going to do in order to factor an expression. The first is to find the greatest common factor. That's why we've been working on greatest common factor this week so far. So first, identify the greatest common factor. You can do this by finding the factor trees and circling the common factors. Or if you know the answer, you just go ahead and you solid with the greatest common factor, then you move on. The second step is to steal that greatest common factor away. So when we distributed, we gave the number on the outside by multiplying. Now we're going to steal it. We're going to take it back. And to do that, we're going to divide. And then the last thing we're going to do is we're going to rewrite the expression with the parentheses and the greatest common factor on the outside. So I have 4 examples for us to go through. So the first step, again, is to find the greatest common factor. The greatest common factor is, with 6 and 12 is 6. If you didn't know that, you can make the factor trees, but the greatest common factor is 6. And so now what I'm going to do is I'm going to steal it away. I'm going to take the 6 back from these. And to steal it, we're going to divide. So 6 divided by 6 is 1, and the x just stays there. And 12 divided by 6 is 2. And so this is my answer. What a lot of 7th graders do is then they want to distribute and try to figure out what x is, but that's not the point right now. The point right now is to factor. So we're unsimplifying. We're taking something away. We're stealing it back by dividing. For 18 and 27, this greatest common factor is a little bit harder, so maybe I'll do the math out. 18 splits into 9 and 2. 9 is 3 and 3. 27 is 3 and 9. So 18 is a 2 and 3 threes. 27 is 3 threes. So then if you remember, what we do is we're trying to find the ones they have in common. 3 times 3 is 9, so my greatest common factor is 9. Then what I do is I'm going to steal that greatest common factor from each term. So I write the 9 on the outside in those parentheses, and then I'm going to divide. 18 divided by 9 is 2. 27 divided by 9 is 3. And that is my factored expression. If you initially thought the greatest common factor was just 3, you wouldn't have it factored all the way. You could go through and factor it. It's just not completely factored if you don't take out the greatest number. For 14 and 21, the greatest common factor is 7. So then I divide. 14 divided by 7 is negative 2x. 21 divided by 7 is 3. And that's my factored expression. So again, you find the greatest common factor, you steal it by dividing, and then you just make sure it's in the proper form. For this last one, I kind of crowded it. When I try to find the greatest common factor, 7 is prime. 9 breaks into 3 and 3. They have no common factors. When that happens, we cannot factor it. When there are no common factors, we write the answer. Cannot be factored. And that's my final answer. Thanks. Bye.